In Jesus' name I've prayed.
Amen. Good morning once again, girls. We are here again for our physics lesson, a new week, and I hope everyone is okay. The challenges we have gone through simply make us become stronger, but we pray that we shall overcome everything, and maybe one day we shall meet even physically and resume our lessons. We left off having talked about a few experiments, especially we are talking about what impurities, how they affect the density of water. We looked at salty water, and then we looked at pure water. To go through, to recap quickly, we discovered that impure water, water that is salty, is more dense than pure water, and therefore when objects are placed in salty water, we discovered that a bigger part of their portion stays above the water and only a smaller fraction is submerged below the water surface. Yet objects seem to sink more when they are in pure water. That was proof enough that pure water was less dense than salty water. I hope that you remember that fact.
Okay, thank you, Mr. Slenderman. Now, last week, girls, I gave you an assignment. Actually, two assignments. Was for you to get 2 eggs, 2 glasses of water, one with fresh water, and then the other one with salty water. And then you place your eggs there and see the level of floating in the 2 different glasses. Then the other one was a question about ventilation. I posted those questions on the Google Classroom. But the one about ventilation, I wanted us to find out or discover, first of all, where the ventilators are placed in the room and why they are placed there. So first things first, can we have people share, those who carried out the egg experiment? Please put up your hands and tell us what you observed. Mr. Sally, there's Namagembe there.
Yes, Namagembe.
Yes, for me, teacher, when I went on and I did the experiment, I got a glass of water without salt and I put the egg, I found out the egg sank, and then I got another glass of water. I put water and I mixed in salt and I put the same egg in the water and the egg was floating on top. But then I went on and I added some more water to that half glass of salty water. And then I found that the egg was floating in the middle this time.
Okay, there's Nama.
Hello?
We have also Lina Jueji. I don't know if Namagembe was through.
Mr.
Hello?
Sally.
Yes.
Teacher, I'm done.
Oh, Namagembe.
Namagembe is done. Let's see Lina Jueji.
Yes.
When I carried out the experiment, I got the same result.
What were your results? You don't want to hear the same results. What did you observe?
When I got 2 eggs, same size, and 2 cups of water. I put the first egg in pure water and it sank mostly, only a little bit was floating. Then when I added salt to the second cup and put the second egg, the egg floated a little more than the first egg. I also noticed that when I put the eggs in water, the top part of the egg is the one that sank and the bottom part is the one that floated.
Oh, the bottom part of the egg and the top part of the egg. That is going to be difficult to explain. How do we know that this part of the egg is the bottom one and the other one is the top one?
I think the wide part is the bottom one and the narrow one is the top one.
Okay. Okay, we are actually, that was a very good observation, and it will work later as you talk about the hydrometer. Maybe Mr. Chakoni will explain better. Those hydrometer have a slightly difference in bases. I think she brought out something that's what I wanted to bring out. Okay. Okay, that was the egg experiment. People, we are not going to dilly-dally about the egg experiment. I think the two participants have explained that well. And we now go to the assignment about the window, the ventilation. Anybody select somebody who can say something about the ventilation? Please, when you put up your ventilation.
For us at home, the ventilators are above the window. So I found the reason was hot air has, the reason why the ventilators are up there is because the hot air has more density. So that it can get out through the hot air has less density, so it will be floating on top of the cool air, so it can go out through the top part, while cool air has more density, so it comes in through the windows, while hot air goes out through the ventilators. Yeah, that's what I found out.
Thank you very much, Crown. That was very good observation. Can we get someone else
Okay,
before we come?
we have Atkunda Vanessa. Atkunda Vanessa.
For me, what I realized is that the ventilators are above the windows and doors. And I think so because they let out warm air, and warm air is less dense than the cool air. So it will be let out easily.
Okay, thank you, Vanessa. Any other person with a different idea, probably?
Trouble. Oh.
It's the same idea.
Oh.
Okay, thank you so much. So that's about the currents, air currents. Like the girls have ably explained, warm air rises and goes through the ventilators, while the cool air comes in the room through the windows. So those are the currents. It's a continuous process. The warm air through the ventilators, the cool air through the windows. Thank you very much. Mr. Sendewe, please take over from there.
I'm going to request you to share a document because you're going to talk about currents now, I think.
There it is.
Okay. Girls, I hope we see this document. It has a subheading saying ocean currents and water density. Is that okay? Mr. Sally, I'm going to request you to select one girl to read for us what is below that subtitle, ocean current.
Crown, your hand is up. Okay, let's see. Gloria Miro. Gloria, say something.
You've told, aren't you said that someone reads what's below the heading?
Yes.
You read, yeah, we have a heading, but you can read what is below the heading. One, there's the note that I know.
Okay. An ocean current is a continuous, directed horizontal movement of seawater from one region to another. Ocean currents can be generated by wind, density differences in seawater caused by temperature, and salinity variations in the water. Ocean currents act much like a conveyor belts, transporting warm water and precipitation from the equator towards the poles and cold.
And the continuation?
Cold water from the poles back to the tropics. Thus, currents regulate global climate, thus helping to counteract the uneven distribution of solar radiation reaching Earth's surface. The density of seawater plays a vital role in causing ocean currents and circulating heat because dense water sinks below the less dense salinity. Yes, below the less dense salinity, temperature, and depth all affect the density of seawater.
Okay. We want to look at something. I hope you girls, you have noted certain things. There are certain facts that have been talked about, creation of ocean currents. And I want us to break down and understand these notes better. There are things that affect the movement of water currents, or what we refer to as ocean currents. First and foremost, the importance of these ocean currents has been pointed out, especially in the control of global climate, or the effect they have on global climate. But they themselves, the ocean currents, have been affected by certain factors. I hope we can look at those factors. But here we're going to concentrate more on density. Can someone name those factors as highlighted? And if possible, there is one that I want somebody to explain. Can first and foremost, as you name the factors, somebody name the factors. Whoever seen those factors that affect the movement of ocean currents, you name them. I want us to list, to kind of like form a list. What are they?
Sally, Beta.
Sorry, teacher, I left my hand up.
All right, let's see Tendo Tamali. Tendo.
So one of the factors they mentioned is temperature. And in the explanation, like from the start, they say like ocean currents help like to regulate the temperature, the global climate actually. So I think like they said, like when we say that air is less is like it's always at the bottom and warm air is always at the top. It's the same with ocean currents. I think the hot, let me call it warm water, is always at the top, and the cold water is always at the bottom, but it's always like you see that screen, the water is always changing, trying to regulate the temperature. That's what I got.
The first fact that you have pointed out is very important. It is temperature. Can somebody point out another factor that is going to affect the water movement or the current? The other factor is?
Okay, I can see.
Let us look at the other factor. What
okay,
is
Yvonne, Eliana.
The other factor.
You only talk about that factor.
The salinity variation in the water.
It is it?
Salinity variation in the water.
Salinity of the water. How do you think the salinity will affect the water movement?
Yvonne, you're still on.
And if possible, what salinity means, because some people may have forgotten what it actually is talking about. What is salinity talking about?
Yvonne?
Teacher, I think, okay, like the salinity, I think is like the salt in the sea waters, like the amount of salt in water.
Very beautiful.
And I'm trying to think of an answer.
Okay, what was the effect of salt in water?
Okay, it affects the density of the water.
How did it affect the density of the water?
It makes it easier for it to hold large volumes. Like
the water becomes more dense.
The water becomes more dense.
It increases the density of the water. Any other factor is pointed out there? There are those factors. I want us to look at them and understand them. There's another one.
Okay, Abigail.
Density variations of seawater.
The density we have talked about that very much. Density variation, okay? What has the density variation got to do? How does it affect the movement of water?
Abigail, you're still on. Abigail, unmute and explain your answer.
Oh, wait, I can unmute.
Abigail, are you there?
Yes.
Yes, explain your answer.
For instance, water which has a lot of salt, it's denser than pure water, pure seawater.
Okay. Okay. How does the density affect the movement of water? Dense water does what? Where does the dense water go? Where does the less dense water go?
Kisa, you're still handling the same.
Can someone help her? When?
Okay, I can see. Yes, let's have Naila. 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 Naila is not speaking. Let's give a chance to Mirembe Nicole. Mirembe Nicole. And Naila, Mirembe Nicole, you're on.
Teacher, I think that the denser water is down and the less dense one is up.
On the top. That is very good. Okay. Then what is our other force factor? The last factor?
Okay, Charity.
The last factor mentioned there.
Charity.
Teacher, for me, I just wanted to explain how density of seawater affects ocean currents.
Okay, quickly. Please do quickly.
Excuse me, Chair, for me, I just wanted to give my explanation.
Do that, but quickly.
Do that very fast.
Of how density of seawater affects ocean currents.
Please do that and quickly.
Okay. What?
Okay, I think she has a challenge. Let's try Vivian Sandra. Vivian.
We have wind.
Wind is wind part of what we have seen in our notes? I want us to talk about those things that have been talked about. There were 4 I told.
It is. Ocean currents can be generated by wind. It's there.
Hey.
Is that all, Mr. Sanjay?
There is one more. They've not seen the other one.
Should we? I think
salinity depth. There is one more. Just one more factor.
Okay, there's Makumbi. Let's try Makumbi.
Makumbi, please.
Can you say temperature?
Temperature has been mentioned.
Temperature has been
mentioned. Density
Let's
has
try
been mentioned. In your
Nasolo.
notes, factor.
Nasolo.
It's depth.
Depth of the water. The depth of the what? Those are the factors that affect the ocean movements. Okay? One is temperature, there is salinity, there is density, there is the depth of the water. I want us to briefly talk about all these things and how they affect from our notes what we are trying to pick up. Because we have read, we want to pick out these facts. Remember that the warmer the water, the less dense it becomes. So this affects movement of water. By when you warm water, we discover that all warm water is always goes to the top to be replaced by the cold water. So cold water sinks and goes down. Okay? Why? We have said that temperature is the factor that affects the density of water. How does it affect it? The moment you increase density, the moment you increase the temperature, that is making the water warm, the density reduces.
Teacher.
Yes, please.
Can you go slowly?
Okay. temperature, okay, let me move slowly. Temperature, the moment you increase temperature, the water becomes warm and therefore less dense, so it moves to the top. To be replaced.
Hello. Ono naye abiipinga bubiipinzi nze nange sigenda mukubira kubanga ye yayagala.
People unmute. We are tapping your.
Yeah, there is interaction.
Okay, let's try to mute them, Mister. You can go on. Let me try to mute them.
Okay.
Yeah, we seem to be tapping undesirable jazz.
Yeah, we are picking a lot of, and it is derailing us. Please unmute listening.
The host needed to make them not to unmute themselves unless asked to do so, but I think that it's now okay.
Okay. Of water or water current, and we are trying to explain. So if you look at that diagram, you are going to see a red current and a blue current. Those colors we are selected deliberately to kind of indicate the temperature of water, red representing warm water, while blue represents cold water. So when water is warm, that warmth makes it expand and therefore reduce its density. So that water will rise to the top of the ocean, and the cold water, which is its temperature is low, will become less dense and move to the bottom. So what happens is that a saturation is set up, and that saturation is what we refer to as a current. So that's how temperature affects, because temperature eventually does affect the density of the water. That is temperature. I hope that is okay. There are some people who are raising their hands up. Was a mistake? Okay. Okay, cold water becomes dense and moves down. Warm water becomes less dense and moves to the top, setting up a saturation. I hope that has been clarified. Then salinity. We are going to discover that different water bodies around the earth, much as they are interconnected, their levels of salt content changes. There will be some water bodies that are more salty compared to others. Okay? Unfortunately, I did not make my research, I did not prepare properly, but I could give you this assignment. Maybe in the oceans, try to find out which of the oceans actually has more salty water, because their salinity is not the same. But we discover that because of that salinity, there is a variation in the densities of those water bodies. Okay? And that also assists the movement as water moves from one point to another, because it will also affect the density. Okay? So these sea bodies do not have the same density. Okay? And then the other term is density, and is the density we have already talked about. Because of their salinity, they have different densities. Okay? And therefore, we have discovered that denser water moves to the bottom, less dense water moves to the top. All that creates movement of water from one point to another. The other factor, though it is less, not as I don't know how I can put it to you at this level, but it is the depth of the water. Depth of the water, later you will discover that it is a little bit connected to the pressure. Altogether, water can be squeezed, but it is most especially the pressure exerted by a water body increases with depth. Okay? And remember that when you exert pressure, you actually are affecting the density of that water body, because you are compressing its molecules. You are making them move together, move closer together, and therefore affecting its volume. And if that volume becomes smaller, eventually the density of such a body becomes greater. Increase in depth increases density. And therefore, we find that that water goes deeper because the water is deep. Okay? So let us try to read maybe through that what has been highlighted on that diagram, the small boxes. We can see what happens as the movement, those small boxes. I'll expect Mr. Sally, select a girl to read what is in those boxes, and then we shall maybe get a better idea of how these facts affect our movement of air currents.
Okay, there's Nalubega Esther. Nalubega.
You read all the 4 boxes, please. We are listening to you.
Surface currents carry warmer, less dense water from the equator to the poles.
Okay.
Warm water from surface currents replaces colder, denser water that sinks in the ocean to the ocean floor. Deep currents carry colder, denser water along the ocean floor from the poles to the equator. Water from deep currents rises to replace water living in surface currents.
Is that okay?
Yeah.
So what we see there is a replacement cycle. As water moves from one side, it is always replaced by cold water, and therefore that cycle or that water current is set up. So we see movement of cold water from the poles. The poles usually are very cold towards the equator, while the warm water moves from the equator towards the poles, and that stabilizes our temperatures around the Earth. Okay? Because of that movement, we find that almost all temperatures, okay, there are certain cold parts of the Earth, but around the equator, for us, we find that we are almost always in the warm seasons, while the people at the poles, they always find themselves in the cold. But that saturation controls the temperature of the Earth. So we must be very careful and look after our nature. We don't change it so much. Remember, overpollution and so on affects the global climate. I think that is my input. I don't know that my colleagues can add more so that we can move to some other point.
There are some answers, Mr. Senjobe.
Yes, select one.
Okay, I can see Chirabo Eunice. Okay, she has gone off. Kalibala and saw something.
Teacher, could you please help me and go back up to the first part of the work? I didn't see it.
Madam. Okay, it is what I've been explaining. Mr. Chakonyi?
Okay, please push that through and you see. No, continue a bit, but we really need to put a limit. Thank you. But go ahead maybe with that student.
Madam Javid, let us see. Read through that quickly, and then we move on. I wish she could read for herself, but I'll read for her. Can you hear me, people?
Yes, we can.
An ocean current is a continuous directed horizontal movement of seawater from one region to another. Ocean currents can be generated by wind density difference in seawater caused by temperature and salinity variations in the water. Okay, those are the things that we listed down: density, temperature, salinity. All those cause variations in the density of the water. So ocean currents act much like a conveyor belt, transporting warm water and precipitation from the equator toward the poles and cold water from the poles back to the tropics. Thus, currents regulate global climate, thus helping to counteract the uneven distribution of solar radiation reaching the Earth's surface. The density of seawater plays a vital role in causing ocean currents and saturating it, because dense water sinks below the less dense. Salinity below the less dense water. Salinity, temperature, and depth also affect the density of the sea water. So we have looked at those different factors that affect the density of sea water. They are basically salinity, their temperature, and the depth. Is that okay? Remember that as water becomes denser, it sinks to the bottom of the seabed, and as it becomes less dense, it moves to the top. That movement is a saturation of cold and warm water, aided by wind, and that wind therefore regulates the global climate, the warmth, the heat around the earth, so that we don't receive too much heat that will eat us up. These days you hear about global warming and so on and so forth. So we find that these currents are almost it is a system that maintains the Earth's global temperatures, okay, so that they don't go beyond excesses and so on. It is a regulator of the temperature of the Earth. Is that okay, people? Are we okay?
Okay, Mr. Senjebe.
Yes, sir.
Thank you very much for that input. I think you have been very, very comprehensive there with the factors which affect the density of water and then the ocean currents and all that. So I wanted to advise our students also to try and find time and watch those videos to reinforce those factors or those points that you have clearly elaborated. They are going to realize that
Mr. Chapon.
I think Mr. Chakony has.
Okay, we have lost him. There are videos that he posted. People, please, you'll go back and you look at those videos. From Nakato Patricia to how does salinity affect it? We said, I hope you are listening in, salinity affects density. I've told you that different water bodies have different salt content. There are water bodies that are more salty than others, and therefore they have a higher density compared. So that density means that an object is likely to float less, to float more in such water, but what will happen is that the water, when water is dense, it goes deeper, and therefore that movement is there. So salinity, temperature, and depth affect density of water. When density of water has been affected, what happens to the water movement? The dense water goes down, the less dense water goes up. I hope people you have got that question. Salinity, temperature, and depth of water, those affect the density of the water. When the density of the water has been affected, what happens to the water? The denser water goes down, the less dense water moves up. And there is a replacement, a cycle. As water moves up, it is replaced by other water that comes from some other place. So water moves from the poles to the equator, and again from the equator to the poles. So whatever water moves has to be replaced, hence setting up a saturation, which we call a current, that movement. I hope that is okay, people. 4 participants raise their hands. We want to move away from that point. I hope these participants are not contributing to the same thing.
Okay, let's try someone new here. Nanyans Sozana.
Yes, teacher. Can temperature affect the density of objects?
Yes. Temperature affects the density. If you increase temperature, you reduce the density. This object becomes less dense because it expands, occupies more space, but the mass is constant, so the density goes down. And when the density goes down, if it is, for example, a fluid, it will rise to the top.
Okay, thank you, teacher.
You're welcome.
Okay, should we give one more chance to another person?
Yes.
Nakafelo, your hand has been up. Nakafelo?
Teacher, my internet wasn't well, so could you please explain that picture of the ocean current? It wasn't well at that part.
You read it yourself. Read it.
Okay.
Then you'll ask where you don't understand.
I think Nakafelo is the last one on that diagram, and then we move on. Please read.
Read Nakafelo. Can you read and so that we can explain to you?
Start from the first box, that surface currents.
Nakafelo.
Surface currents carry warmer, less dense water from the equator to the poles. Warm water from surface currents replaces colder, denser water that sinks to the ocean floor. Deep currents carry colder, denser water along the ocean floor from the poles to the equator. Water from deep currents rises to replace water living in surface currents.
Okay, so if I explain that cycle, I've said that the dense water the less dense water is located at the surface of the sea or the ocean. Is that okay? And it moves towards the poles. As it moves away, it has to be replaced because we don't create vacuums or empty spaces. So when the warm water moves towards from the equator to the poles, it is replaced by water from the poles to the equator. The water that replaces it, if you look at the water that comes from the poles to the equator, it moves below, under. It is for it is located deep down there in the ocean. It is at a lower level. So it moves towards the equator. But at the surface, warm water is moving from the equator to the poles. So there is a cycle or a circular movement of water, and that is what we call our ocean currents. Is that okay? I hope we are done with that. People will listen in later, and maybe we also, as more notes will be given, we shall discuss that in greater detail. Is Mr.
Sanjobe?
Yes, Evo?
There's one from the chart, how wind affects ocean currents.
How windy?
Had you addressed that?
Okay.
No, you had.
The wind, when the wind blows over the water, it accelerates the movement of that water. Wind is like an accelerator. It improves the movement of that water. And in most cases, it also blows. You know, we have different currents. That's the problem with wind, because sometimes it changes direction according to the currents. I wanted to bring in the wind effect more when we discuss the sea breezes. But wind moves in a direction where, okay, the warm water rises. Remember, the warm wind rises, it goes to the top, and it is always replaced by the cold wind, and a saturation is set up. But I thought we'll discuss that better when we talk about the sea breezes. I don't know what it is.
Okay. I think that's okay. There are some two people here who have been having their hands up. Naila, Nantale. Naila, you there? Okay, she's not responding. Atukunda Vanessa.
Teacher, I just wanted to ask, you say that pressure exerted on a water body increases with depth. Like, I don't understand exactly where does the pressure come from when like the depth is a lot. I am not understanding that very well.
Mr. Sanjobe?
Yes, please, sir.
I think that one will come in when we look at pressure. It will be well explained there.
That's what I was going to tell her. That pressure is, I know they talked about it here, they brought it about it as a factor here, but it will better discuss later. I will talk about the pressure exerted by an object. We are going to request that some of these things that we have discussed come a little bit later in our discussions. At this moment, let us just keep them or store them somewhere, keep them. We know they affect the density of water. Then we shall discuss them in greater detail as we break down our topic of physics. Please, girls, will be patient with that topic because it will be, even the sea, the wind, and so on, those other facts will come in slightly later, okay? They will come in and we shall be trying to connect these things so that you get a better understanding of the concept about currents, okay? Can we now move to that heading, density and purity? Ozana still has the Nyanzi Ozana has a hand up. Two participants, Mr. Sali.
All right, let me see them. Nyanzi Ozana.
Thanks, sir. Another question: can like temperature affect like density of objects in water?
Mr. Senjo.
The object has been placed in water.
Yes.
And then the temperature increases in the water. Or you warm the water. That's what I'm trying to understand.
Yes, and I'm saying, like, can temperature affect the density of objects in water? That's what I'm asking.
I don't know whether when I say that now you have compound objects, whether you understand, but you have an object that is water, you have a water body, you have an object. Is that what you're talking about? And then you change the temperature of that body, both bodies, water and the body.
Yes.
So both of them, if they are warm, their densities will reduce.
Oh.
Because as you are warming the water, you are also warming the object, and therefore the chances are their densities will reduce.
Oh, thank you, teacher.
Is that okay? Have you ever boiled beans? Now that is one of the things that I would want you to talk about. You put some beans, put them in water, boil them, see the observation. Better get interested in some of those things, lady. Okay? Mr. Chakonyi has a hand up. Mr. Chakonyi, you participate, please.
I have lost my co-host rights, but what I wanted to say, that other student who was talking about pressure, yes, we could perhaps tell her that when you have deep water, the molecules get too much packed. There's a lot of packing of the molecules, and this close packing, because of the too much water which is above, the molecules at the bottom, there's going to be close packing of the molecules and consequently altering the density of water or making the density of water to be higher. Because she was
let me
continue. It's a little bit of a higher concept as of now, but you can help understand that where you have deep water, you have got the molecules closely packed now because of the too much pushing from up going down, consequently making the density to be higher and bring about the density variations in the different regions.
Okay, thank you, Mr. Chakonyi. I hope you have heard, girls. Pressure compresses.
Tell him to give me back my rights if possible. Thank you.
Okay, girls, listen. Pressure compresses the water, the molecules move closer, their volume therefore decreases, whereas mass is constant and therefore the density increases. I hope you have heard that. Okay? Okay, girls, let's move to density and purity. I think the participants are down, the contributions. I think we are trying to answer as many questions as we can on that. Density and purity. I think we said that one of the uses or why we study density, it assists us to determine the purity of an object. Okay? When an object is pure, it has a specific density or a value that corresponds to its density. The moment that value changes, then we know that this object or this item has maybe impurities in it. It has been mixed with something that has caused its density to change. So when we look at the density values, they help us to understand or to identify an object because of the value that we expect that object to have as it to represent its density. The example that has been given there is of gold. and the value for gold is 19.3. If we got any other value, for example, 20 or something that is less, then we know that that is not pure gold because there could be some other impurities that have affected its purity. So the values of density enable us to identify and determine objects and whether they are pure or they are impure. Richard Chakonye, you still have your arm raised up. Please say something. Mr. Chakonye, Mr. Sali, allow Mr. Chakonye to say something.
I have unmuted him.
Sorry. Okay, thank you, sir. Thank you. No, I don't have any concern as of now. Please go ahead. I think my hand had remained.
Okay. And you have been made a co-host again.
Okay. So you are always going to discover that you are given a certain table.
Yeah, thank you. I've realized that.
Okay. You are given a table exhibiting densities of substances. Yes, madam, you can show us that table. So we have that table. That table shows us densities of common substances. I want specifically somebody to tell us the density of water. That value is very, very important. The density of water. Mr. Sali, select a girl to read for us the density of water.
Yes, Nasol, I can see Nasolo. Nasolo. Nasolo, and are you there?
Yes.
Mm.
It's 1 gram per cc.
It's 1 gram, okay? Very good.
Yeah.
Now, there are some density values that are almost alike. Can we point out those density values that are almost alike?
Eunice.
The one for methylated spirits and paraffin.
What about petrol?
Yeah, it's one gram less.
What about polythene?
1 gram.
Polythene is 1.
No, it's like it's 1 gram more than the one for methylated spirits and paraffin.
I want you to read these values. Don't read them the way it is just reading. Methylated spirit 0.8, paraffin 0.8, petrol 0.7, polythene 0.9. Mr. Sally, there is a hand there, but I wanted somebody to also look at lubricating oil.
Okay, Narule Hannah.
What is the, I cannot see my waiters. I see a hand there.
Narule, selected.
What is the value for
it is 0.9.
0.9. Okay. Now, can somebody tell me what is common about those substances?
Okay, such like Daniela. Such has disappeared. Okay. Okay, such like is here. Daniela.
They're almost the same.
Yes, they are almost the same.
Some of them are more by 1 or less than 1 by 1.
Okay, that is very good. They almost have identical densities. But what can we say about their source especially?
Okay, Mwanguzi, someone here. Mwanguzi, me.
They are all less dense than water, meaning they'll float.
Okay, I'm not going to delay a lot, but we are going to discover that almost all those materials, if you look at lubricating oil, methylated spirits, paraffin, petrol, polythene. They are almost what we refer to as byproducts. They come from the same source. Altogether, it depends on what you actually want to generate out of them. It depends on the nature of purification. You will study more about those oils. But all those things, substances, we can talk about them as being plastics, etc. They are related. They are generated almost from the same source. They are petroleum products, if I may put it, because now Uganda, we are interested in that industry. So when objects almost come from the same source, their densities are very close. That's what I wanted you to know, to notice about, because you may, for example, I've told you that we may determine the purity of a substance. Suppose you got your density as 0.8. Would you be able to distinguish whether it is methylated spirit or it is paraffin? Altogether, there they would, I think, would get a confusion, isn't it? Altogether, girls? They are muted, unmute the girls, because I want to bring out some other component, Mr. Sally.
Okay. Okay, Namagembe. Namagembe, you let me unmute a few of them. Yes, Mr.
Okay.
Sanjay, go on.
Teacher, I just...
Yes.
Mr. Sanjay, go on.
So I'm asking one of the girls, how would you therefore, if density alone has not been able to differentiate between methylated spirit and paraffin, what more would you do to distinguish between those two? Can somebody tell us how she would distinguish paraffin from methylated spirit?
Okay, Namagembe Majo. Yes.
Teacher, for me, I would get the paraffin. I would get paraffin and pour it on pure water. And if I find out that it floats, then I'll know that it's paraffin. Then I'll get the meth. Sorry, I didn't get the word properly. Then I will get it and I pour it on water too, and find out. Yeah, I also get and I pour it on water. So if I find out that I now also find out if it either sinks or it floats, then I'll know the difference. If it sinks, then I know if it doesn't float, then I know it's the methylated spirit. Then if it's paraffin and it floats, then I'll know it's paraffin. Because paraffin obviously it floats on water, it doesn't sink. It's less dense than water. So that's how I can know.
So, but they are both going to float. Now, what would you do? Because both methylated spirit and the paraffin have floated. Can somebody else tell us how she would distinguish between paraffin and methylated spirit?
Okay, Narule. Narule.
Teacher,
yes?
I think that I may use the boiling point and the melting point, because I think they have different boiling point and melting point.
Beautiful. Thank you so much. So one of the other ways you can distinguish between these substances that are having almost identical densities, therefore you cannot distinguish them by density only. One of the other factors she has pointed out is using their boiling points. Is that okay? I think that is one factor we wanted to generate. That helps you to distinguish. Density has failed, now you are using another property. Is that okay? So is there any other property that can be used?
Naka fellow Eunice.
Apart from boiling,
fractional distillation. Fractional distillation.
Fractional distillation. You have taken us in a subject we have almost also forgotten. For us, we want physics.
That is chemistry.
That is chemistry.
Okay.
So
thank
has pointed out boiling points. I want to see methylated spirit and paraffin. Any other point you can use. You are scientists now.
Let's try Yvonne. Thank you, Eunice. Then Yvonne. Yvonne. No, sorry. Put your hand up. Okay, as she comes back. Kwagara, unmute.
Teacher, can you say the melting point?
Yes, we have mentioned that. Melting point, boiling point.
It has been mentioned. Let's see, Yvonne.
You people, you are scientists. You use your.
Yvonne.
Okay, like I'm not sure how this is going to help, but I read it somewhere that the conductivity of a substance.
Beautiful. Conductivity over substance. But maybe this is water or these are liquids. I don't know how conductivity will help you so much, but conductivity is a very beautiful, especially when it comes to solids. Conductivity is one other way to define. So that is, we shall keep conductivity and because we shall talk about a specific heat capacity. You will keep that word also. That is one of the things that is going to help you. Conductivity, I don't know that I talk about electricity or you are talking about heat, but those are some of the other things that tests that you carry out to identify substances. But there is one that you carry out, methylated spirit and paraffin, people.
There's our default, Crown.
Okay, teacher, I have two answers. Since these are liquids, I think the freezing point and the refractive index. I don't know, just I think.
You think?
Yes.
Okay. It is a good point to note. Maybe I'll look at refractive index. I'll also dig deeper in refractive index. But I wanted something that is very common. You people, apart, somebody talked about fractional distillation, but there's something that you also use to identify items in your chemistry. Spirit and paraffin.
Okay, there's Eunice.
I think use their smell, the way they smell, because they smell different.
Beautiful smell. Altogether, you use your senses. One of the senses that you use to identify objects is smelling them. Isn't it true, people? Okay, you may not get, but smell, those senses are very, very important. Okay, the other factor that I will tell you is that you can pour both of them on your hand. I think most of you use deodorants. Yeah, you know what deodorants are, all those perfumes and so on. They have different temperature, or some liquids melt faster. Oh, actually not melting, evaporate faster than others. Those are some of the simple things that you can carry out, especially I was talking about liquids in this case. With the solids, there are other tests and so on. So people, much as we are saying that density can be used to determine purity, there are other tests that you can carry out, especially where densities seem to be identical, to distinguish between substances. So one of them is the melting point, as has been pointed out. We can use the sense of smell in case those items give off a smell or they have an odor. We can use conductivity. She has mentioned conductivity and other physical tests to prove that these subjects are what I think them to be. So at our level in S1, I wanted us to recognize smell is quite important. Number two, boiling points are quite important. And then density is also very important. Those are some of the things that we use to identify.
Mr. Sanjove.
Stroke melting point, yes, sir.
It's already 10. There's one hand up.
Yeah, I was actually winding up.
Yes.
Mr. Sally, please.
Okay, Narule, it seems you have something burning.
Teacher, about like the time they reach to make a flame.
What will that point be when they are making a flame?
I don't know.
Ignition point. Their ignition point. But some of those tests anyway should be carried out because some of them we see are volatile. Some of them actually in chemistry, the moment you expose them to the atmosphere, they immediately burn. So those are ignition points. It is an ignition point at the temperature at which it catches fire or it turns to fire. So it is an ignition point. Okay, girls, any other questions you want to wind up? We have not been able to go into relative density. We shall handle it later.
Mr. Sanjeev.
I
wanted to imagine that maybe the student wanted to mean flammability, because some liquids are highly flammable, others do burn but not highly flammable.
Yes.
Most probably that's what she wanted to talk about, because the petrol and the diesel and the kerosene all burn, But
Yes.
the flammability, of course, is quite different. Petrol being highly volatile and therefore burns kind of explosively. And then the flammability being kind of different. But it is the point anyway, she brought it out. Thank you.
Okay. Yes, sir.
Mubezi Karen Mubezi.
Excuse me, teacher. I wanted to ask whether you're going to put the notes on Google Classroom because I don't have the physics prototype.
It is there. It was put there in the first week. Maybe we shall reload it.
But everything in physics was loaded there. The small notes that we give you are small supplements. The notes are very, very summarized, by the way, just to pick out the key points. So it does not stop from reading and enriching them.
Sandra,
I want to know that.
There's one more.
Can you please send this recorded lesson and for last time on Google Classroom?
Okay, we are going
That is done by our administrator, Mr. Oluka Bruno. It is his responsibility, so I hope it will be there.
Okay.
We don't seem to have questions.
Yes.
Vivian, Sandra. Is it Vivian?
She's done Quaz, just asked.
There's somebody whose hand is up.
No, I'm not seeing anyone, Mr. Sanjay.
Okay. So those who want to stop here for today, the contributions, the participation was excellent. There is a bullshit.
Mr. Senjere.
Only any bullshit,
There is somebody who was using foreign language. I think we need to identify that student.
Yes, this one should be Mr. Oluka help us to bullshit.
This is unacceptable language here.
Mr. Oluka, please, you just delete that person.
This one?
I'm here to say. Bamita bullshit.
That kind of language is unacceptable in this.
Yes, bullshit was putting up her hand. So if she's really bullshit, let's bullshit her.
Completely out.
Okay.
Can you share the name of the person? I don't see. Where is it on the chat?
I've removed the person and reported the case.
Okay, thank you so much. Okay, we stop here. We are going, please check, we are going to post a few notes.